Hello, my name is Taylor Murray, and I am a senior in the honors program and majoring in computer science. And today I'm going to talk to you about my honors capstone, which was a MDP project in collaboration with ProQuest on sentiment analysis. So a little bit about this project. The context. Our sponsor was ProQuest, like I said. They are an education technology company. Primarily, they're helping academic researchers access lots of textual data. So their content collection encompasses 90,000 authoritative sources. It has 6 billion digital pages, and it spans 6 centuries, so lots of data. The motivations for this project were to enhance user experience in their new text data mining, or TDM, environment, and also to improve ProQuest's own internal use of data. So how are we going to do this exactly? The high-level goals for this project were to help ProQuest users create their own word embeddings on their own specific corpora, which they can access in ProQuest, and also to be able to predict sentiment on their own data sets. You don't need to know exactly what word embeddings are right now, but you should know that they help sentiment analysis, or they can be used in sentiment analysis. So word embeddings, we have a part of our goal is to have a word embedding system. Next part is to have a sentiment analysis system, and then finally an evaluation system to figure out which models perform the best on various sentiment analysis data sets. Word embeddings, quick refresher, are just representations of words in the vector space. So, for example, you'll have an X number of elements in your array, and each of those elements corresponds to a certain property. And say, for example, you have cat here. Cats are felines, so the second property we have here, we're going to have that as a 0.9. So the values range from -1 to 1 on how much they correlate. So -1 would be not correlated at all, 1 would be very much correlated. So 0.9, pretty correlated to being feline. On the other hand, something like royalty, cats are not royal, mostly associated with royalty, so we got -0.7 there. Usually the vector is chosen to be between 50 and 300 elements long, and so we have a shortened version here. Also, an advantage is that each word embedding takes up constant space, so the more words you add, the space that one word takes up doesn't change, which is a nice feature. So as I said before, these word embeddings can be used in sentiment analysis. So we take in labeled data, which is just sentences with labels. So in this case, because we're doing sentiment, they'll be labeled with emotion. And we also take in word embeddings. We split the data up. So 80% we're going to train on that, 20% we're going to test on that. We take in the machine learning model we want to use. So we use classification. We're going to output 1 emotion label from 9 emotions. And then we're going to take that after we train it, we're going to evaluate it on the labeled sentences we didn't look at, save the model, and then that can be used by ProQuest researchers on their own unlabeled data. Okay, so we have 3 ProQuest corpora given to us. We have New York Times, which is obituaries, op-eds, historical events, wedding announcements, lots of New York Times data, and that spans from 1960 to 2000. We also have book blurbs, which are just little sentences, parts of books. And then we have LION, which stands for Literature Online Poems. And so we can use all of these to create word embeddings, because word embeddings creation is an unsupervised machine learning task, so we don't need labeled data. However, to do sentiment analysis, which we wanted to do, we had to label the data. So we did New York Times and LION, a subset of both of those, and truthed it, or motion labeled it, basically. And this brings us to our key question, which was, can using in-domain corpora for word embeddings training, can that improve our sentiment analysis performance? So if we have word embeddings trained on LION corpora, LION poems, then can that, if we use those word embeddings in our sentiment analysis model to train, will that sentiment analysis model be able to beat all the others on that LION poems sentiment analysis task, is our question. So what did we discover? We tested 18 models, 9 of which used custom word embeddings, and we used different sampling techniques, filtering methods, machine learning models, and sentence embeddings. But in the end, it seemed pretty conclusive that more generally trained models performed the best. So in the graph here, we're comparing macro F1 scores for sentiment analysis on 5 different data sets. And the last one you see on the right, that's an aggregate of the previous 4. So we would have expected especially to see a higher performance of our best model on the New York Times and the Poems data set, because we were training on those data sets in some cases for our word embeddings. But unfortunately, the external best model seems to have done the best. And even further, we can see that in each of these cases, in the first case, you'll want to see, like, for each of these emotions we have here, we want the line poems, which is the blue bar, to be the highest in each of these cases, because this is testing on line poems. However, we don't really see that. It's very all over the place. And similarly, for the graphs on the right, we have, this is tested on New York Times data, so we'd want to see the New York Times, which is the New York Times sentiment analysis model trained with New York Times word embeddings, which is the red bar, perform the best. But we don't. It's kind of all over the place. So we weren't able to determine that this in-domain corpora was correlated with better performance on the sentiment analysis tasks. However, we did deliver something for this project. We made these Jupyter notebooks, which are kind of just walking through code on how to make your own word embeddings, how to use actually them, so give them some examples of what they can do with the word embeddings. We give them sentiment analysis models, so predicting affective state, which is just like emotion, like we said before, predicting valence state, so predicting in a class, is it very negative, is it positive. We also gave them visualizations for different sentiment analysis results, as well as we gave ProQuest our own word embeddings, our set of sentiment analysis models, and emotion labeled data. So, lesson I learned from this is that you should record all of your parameters when researching, and you should brainstorm the ones you might try later. So we noted 4 parameters, I think, in our specifications for our data, so our results, right? But we failed to note, like, more than what I mentioned here, but at least 4 other parameters that we changed later on. And so we wish that, we would have noted that we were doing something with it earlier, saying, like, no undersampling or oversampling done. So then we can note, oh, now we're doing under or oversampling. So I think that it's important to brainstorm what you're going to do, but also just note the things you think, like, well, we're just going to keep this the same always, so we don't need to note this parameter down. You might actually change it. So anything, it doesn't matter if you think it's relevant, write everything down, and also brainstorm what you think you might be able to change later. I got involved in this project because I was interested in machine learning after taking EECS 445, and I wanted to try my hand at research, which I got to do. And I also really enjoy the psychological aspect of this project, and thinking about the human component and how we derive sentiment was really interesting to me. Some further steps for this project is thinking about emotion as a vector. So we tried to do this as like either you're this or you're this. You can't be both, really. And so, like, something we classified as anger, if we classified it as sadness instead, that would be a 0. We got that wrong. But maybe thinking about how it's closer to sadness than it would be like happiness, right? So trying to think about emotion as a more continuous thing. Also using word embeddings for optical character recognition. So trying to determine if something is spelled wrong because it was recognized by this machine learning program. Can we notice that and actually know what the word was supposed to be is another thing we could do. And also adding a neutral filter. So thinking about can we take out all of the neutrals? We had a problem with too many of our labels were neutral. So figuring out how we could kind of take out all the neutrals first and then categorize on just the emotion stuff was something that they might try later. I want to thank our sponsored partners from ProQuest, John Dillon and Dan Hepp, who are very important to us. Our advisor, Sugi, and also the team, Pranay, Vishnu, Arun, Emi, Rakshit, and Sebastian. Couldn't have done it without them. Thank you.